Welcome back for another 7 Caillou challenge called Heron's Formula. Write function Heron, which calculates the area of a triangle with sides A, B, and C. They provide Heron's formula for you, which is the square root of the quantity s times s minus a times quantity s minus b times quantity s minus c, where s equals a plus b plus c over 2. Output should have 2 digits precision. So, very simple what they're looking for. They provided us with the formula itself, so the only task is to translate from English or mathematical language into C#. Let's do that. Go ahead and pause. Try this one out. I know you can do it. Come on back when you're ready. Okay, first things first. What I'm going to do is make a little helper function that'll just calculate s for me. And so I don't have to repeat it when I eventually go to give the answer and write out this square root of this quantity here. I don't want to keep writing out a plus b plus c over 2 for each place that s is shown here. That's why I'm choosing to do it that way. So I'll say private static double, let's call it calc s, and it'll take 3 parameters, double a, double b, and double c. And finally return the quantity a plus b plus c divided by 2. Now a couple notes here. I used parentheses around the a plus b plus c because if you look up your order of operations, the precedence of the mathematical operators, you'll notice that division is higher precedence than addition. So if I didn't have the parentheses, it would run the c over 2 first and then say a plus b plus c over 2. And I don't want that. That clearly is a different result than if I add these numbers first and divide that sum by 2. So that's why I did that. Because we're using doubles everywhere, or I should say for the parameters here, I can get away with writing it out like this. But remember, if you have integer parameters and you say something like divide by the integer 2, it's going to use integer division and it's going to truncate the result. So that's fine if the sum happens to be even. If it's odd, you're going to have a remainder of 1/2, right? And with integers, it'll just truncate that and throw the 1/2 away. And so when you're newer and you run into situations like that, it seems like the computer's doing the math wrong. And just know that those kind of quirks can happen. It's not really spelled out for you, but eventually you figure out things work that way, and that's why I'm here telling you about that. So this should be fine because everything's a double. If you need to get to doubles, you can also explicitly make this value a double. You know, that the little f I put after it denotes that it's a floating point value, which doubles are. They have double precision, so they would be more precise than a standard float, which I believe would be single point precision. You can read more about that, or maybe I'll do a video about it if it's confusing for people. But anyways, I'll just leave it by 2. That should be fine. And then the idea is that I can just set up once here. I can say double s equals calc s for a, b, and c. And then I can just reference this s in my formula here, right? I don't have to keep writing a, b, and c out. And I could also put calc s, a, b, and c everywhere s is shown, but the difference would be that it's performing this calculation every time. So what, 4 times in this formula? And what you see programmers do often is we'll cache a result of a calculation here, especially an expensive one, and that way we already have the answer. We don't need to perform calc s 4 times. It's wasteful, right? The result doesn't change if the parameters are the same, right? So there's no point in me running it 4 times in a row on the same inputs. So that's the idea there. Here, this is, this can be calculated very cheaply, so it's not a big deal. If you did this in a professional setting and you repeatedly called this, nobody's going to give you a hard time, and nobody may even notice unless they're looking at your code. But just know that I want to get you in that mindset of understanding how things work and best practices. So anyways, with that said, we'll get into our result here. Return math, and open up your math documentation here. If you use your search engine and say C# math class, you'll land here. If you expand your methods, you can see all the advanced math you can do and simple math you can do with the math class. And there's one called square root, does what you think it does. And we'll also use this round one, which you've probably seen by now if you've been with me, which will get us to that 2 digits of precision that they required for this challenge. So if you want, you can look at square root. You give it a double value, it returns a double with the square root. You know, not much to say, right? It does exactly what you want it to do. So this whole thing is going to evaluate to a double, right? S is a double. Subtracting a double from a double is a double. So it's multiplying a bunch of doubles. Those are going to come out as a double. So let's put the formula in. We have S times S minus A times S minus B times quantity S minus C. And see how readily that translated? Nice and simple, right? Again, I use the parentheses because of order of operations. Multiplication and division, they're on the same level of precedence, and they're both above higher precedence, that is, than addition and subtraction. So now we're dealing with multiplication and subtraction, but it's the same kind of thing going on as with when you use division and addition. So, and they even put those in there for us too. So that should cover our formula. The last bit is this 2 digits of precision. If you were back in your math class looking around, you would have noticed round. And that's why I say to keep a tab open with these method lists expanded, and you can just scan those and you start to memorize them over time. And it rounds the value to the nearest integer or the specified number of fractional digits, which is what we want. We're going to use this really simple overload here. You can see all the different kinds you can do, but we just want to say, hey, we want to give you the input that we want rounded and then just a number of digits. So feel free to read more about that if you like. We're going to wrap this whole thing then in math, round, that quantity, and I'm putting 2 for 2 digits. And so that should be that. Test is green, and I'm green to submit. I had calculated this already, that's why I don't have to hit the attempt. So that covers it, I think. If you wanted, you could have broken this out on another line, right? You could have stored this whole result into another double variable and then called math round on that variable in 2, but I'm sure by now you're getting more comfortable with sort of chaining methods together. And this is still very readable in my opinion, so I will leave mine like that. I'm going to go ahead and submit and collect those points. Don't imagine there's a lot of variety in solutions, but never hurts to take a quick scan through them. You can see they did the same thing we did. It's a very common solution. And again, the same thing. I don't see the rounding, but that's okay. So yeah, feel free to look through those all you like. Otherwise, you know where to find me if you have questions and comments. Thanks for watching. I'll see you in another video.